systems with three variables. The example,
Where does it start?
right here, the example where it starts is right here in the bracket. That's the problem we're going to go through. So
The bracket is the problem?
yes, get the bracket down. Systems with three variables. We know how to solve systems, or you learn how to solve systems of two variables. There were three methods. It was graphing, substitution, elimination. With three variables, I would always use elimination. That's the easiest way to do it. You always want to get them in standard form, which is x plus y plus z equals the constant, and just line them up in that order if they're not already done so for you. In this case, it's set up perfectly for you.
How do you want to line it up?
X plus y plus z equals the constant. Okay, standard form. Now, I said to use elimination. Now you're going to have to use it more than once because we have three equations, three variables. So the first thing I did here, I looked at it and determined that the y would be the easiest variable to eliminate. Do you agree with that?
Yeah.
Okay, because you have a negative 3y, a positive 3y, and a negative 3y. So what I did, I took the second equation and third equation first.
Why not the first?
You can. It doesn't matter the order,
Okay.
but I'm going to do that next. Okay, I took the second and third, lined them up, and just added the two together. So you get 6x minus 2z equals 34. Give you a second to write that down. If you have a question, let me know.
Why would it be?
So if you had like 3z and then it had minus 2z and minus z, then could you cancel out those?
Wait, say it one more time. 3z.
Positive 3z, but the one in the middle was or minus 2z,
Mhm.
and then the last one was just minus z. Could you cancel out the z?
You could, but you got to do work to get them canceled. You'll have to multiply one of the equations by something, and we'll do one of those in a second.
Yeah.
I don't want to eliminate z's here.
I know. But
I mean, you could eliminate z's here.
hypotheticals.
Yes.
So when you get it like this, you can find the x and the z axis. Intersect. You can just cover up 6x and then divide -2 by 34.
No, we're not. We can't solve anything from that step. We're not even close to being done yet. Okay. So what I have to do next is what Zach said. Now you have to use the one equation you didn't use the first time, which was the first one. And I had to combine it with one of these two to eliminate the same variable you did here. We eliminated y, so we have to eliminate y when I use the first equation. So it's easiest to combine 1 and 2 because you have negative 3y and positive 3y again. So what I did, I took equations 1 and 2 and added those together to get 3x plus 2z equals 11.
Why isn't that 7x?
Where?
You're adding up all that.
What?
Because he just
Yeah,
said
he
that
used
bottom
two.
two.
Yeah, you only use 2, you don't use a 3.
Yeah, we're combining two of them at a time. All right, so now, once we get here, I got 3x plus 2z equals 11. Now I can take what I got here and combine it with this one. So I just rewrote that one as 6x minus 2z equals 34. Then I can combine these two using elimination again. I can eliminate the z as easy as to eliminate. You end up with 9x equals 45. Divide both sides by 9, x comes out to be 5. Once you get that first solution, everything else falls into place. Because once I get x to be 5, what can I find out next? What's the easiest to find out? Z. Because of here. I can plug 5 into one of these two and solve for z. Let's see where I plugged it in.
Probably
Z is
three.
equals -2.
So I plugged it into
Three.
the
On the
3. Yeah, right underneath.
Oh,
Okay. So I took the x equals 5 and plugged it in here. So 3 times 5 plus 2z equals 11. And then solve for z. 15 plus 2z equals 11. 2z equals negative 4, z is negative 2. Okay? Now I have two of my unknowns. I have x and z. Once you have two of them, you can plug it into any of the three originals. I plugged it in
The first one?
to the last one, I believe. I
Yeah,
plugged
the
it in.
last one.
Yeah, 4x minus 3y minus z equals 19. I plugged in the x and the z, and I came out with y to be negative 1. So here's your solution. 5, negative 2, 1.
Where did you plug in the Z?
Plug the z, I plug the x and the z into the third original equation. You can plug it
So
into
Z
any of the
goes before-
originals. What?
Z goes before, y in the bracket, or?
No,
right there,
z's,
right?
z's your last. It goes x, y, z.
Use the switch negative
Oh, you're right.
That's
Okay.
interesting.
So that should be 5, 1, negative 2. Very good. Let's fix that up here.
So that sign
That's
that
why I'm
was
so
making
confused.
for you, should I just tell her to stop?
What?
The one that says, have you ever known me to be wrong?
Yeah.
two. You were
So it
just
should be
wrong.
5, 1, negative 2.
It's on camera too.
Yeah, probably
Oh,
shouldn't put this on YouTube.
That's embarrassing.
Yeah, should we
Yeah, you
teach
should.
this?
That's smart.
Alright, so
Yeah.
5, 1, negative 2 is the answer.
So that took like 5 minutes to do one problem,
Correct.
so we shouldn't have like 2 problems.
Okay. Next,
I have no idea.
all right, this one you gotta do a little bit more work. The original problem is right here. 2x plus y minus z equals 5, x plus 4y plus 2z equals 16, and 15x plus 6y minus 2z equals 12. I chose to eliminate the z's. And what I would do, or what we did here, is we took the 2 and 3, equations 2 and 3.
Is
Right
it best
here.
just to do 2 and 3 to start off with?
It depends.
Wait, which one did you start with?
It won't always be 2 and 3. I start with 2 and 3, the last two, right here. So we came across in this case.
2 and 3, shouldn't it be 16?
It's going to be. I just rewrote equations 2 and 3.
Never mind.
Okay, and then added them to get 16x plus 10y equals 28. All right, then which ones did we combine with? Had to use 1. And I multiplied the top by 2, and I combined it with equation 2. That way the z's will eliminate.
What'd you multiply by 2?
I multiplied the top equation by 2.
Why?
So the z's would eliminate when I put these two together.
So you can just multiply.
They have to have the same coefficient, they have to be opposites of each other. So yeah, you multiply the whole thing by 2, you get 4x plus 2y minus 2z equals
So
10,
you can just multiply by anything, so you can.
as long as you do everything, the whole equation. Then you have x plus 4y plus 2z equals 16. Now combine these two to get 5x plus 6y equals 26. Everybody with me up to this point? Then I took it and combined it over here with our result from the first time. And I chose at this point, here let me put a bracket there. So there's my new system. I chose at this point to eliminate the y's by multiplying the top by 3. I end up with this. Bottom by -5, I end up with this. Add them together, you end up with 23x equals -46. So x comes out to be -2. And again, once you get that first one, you're set. Okay, took a lot of steps to get to the first one, but once you're there, it goes by fast.
So then once you have X, you gotta put it into one of those two.
Once I get x, I plugged it in, where did we plug it in? We plugged it in.
You have to either do it
This
to
one.
16x plus 10y,
This
or
is
5x plus 6y.
Correct. You have to do it where there's only one other unknown. Okay, you can't do it where there's two unknowns. So I plugged it into here. X is -2, and I get x or y to be 6. And then once you have your 2, any 2, you can plug it into any of the originals. Let's see where we plugged it in. I plugged it into, which one is that?
It's the second and
X plus 4y, which one's x plus 4y?
The second one.
Second one? Yeah. So, and z comes out to be -3. So your solution should be -2, 6, -3.